Hello, today I'm going to talk about the Laplace transform, and what that is a method for solving differential equations using fractions. It's essentially it. What it does is you use a formula to convert a function of, let's say, t, or any variable they give you. Say they give you a function of t. You're going to convert that to a function of typically s. And what's special about this function is no matter what this one is typically fractions, and once you get to the fractions, you can just solve the problem normally. So the whole trick is this transform from anything to fractions. And typically, this is how it works. Let's say they give you this function at f of t. It could be anything. You'll transform it to the fractions, and then what you do is you simplify everything a little bit using partial fractions. That comes from Calculus 2 when you're solving complex fraction integrals. And once you use partial fractions, you have a simpler fraction that is still this, it's just simple. And then you do an inverse transform, which is just the opposite of this. You do this inverse transform, and you get your answer to f of t. So this transform right here, you can do it one of two ways. One, you could look at a table, which is the easier way, so I'd say the smarter way. Or two, you can do the math, which I would say is the more fun way, but the more annoying way. So if we look at the math way, that transform, so the transform, which we'll call capital F of s, of any function, we'll say the function is f of t. So this is the transform of f of t, will equal the integral from 0 to infinity of your original function, whatever they give you, times e to the negative st, where s is your new variable and t is your old variable, all with respect to t. So that's really it. So let's just use the example of f of t equaling e to the t. So by the logic, we should get a fraction once we're done with this integral. And then we will have our transform. So let us plug this into the formula. So if this is e to the t, then our transform with respect to s, the new variable, is going to be the integral from 0 to infinity of e to the t times e to the negative st dt. This is just plugging this into the formula. And because this part of the formula is annoying, just for this specific example, or anything with an e, I'm going to combine these two using exponential rules, because integrating this by parts would just be annoying. So if we combine e to the t times e to the negative st, we can just add the exponents. So we'll get e to the t minus st, and if we pull out a t, that's e to the t times 1 minus s. So when we put this back in for this complex part, we now just have the integral from 0 to infinity of e to the t times 1 minus s dt. And this is a simple integral because 1 minus s is just a constant when you're looking at the variable t. So you can just treat this as integrating e to the power of a constant times t, and that will equal 1 over 1 minus s times e to the original thing, which is t times 1 minus s. And then, because it's a definite integral, we can't forget the limits from 0 to infinity. And you can see two things. You can see that here's where the fraction is starting, because remember, the transform is going to be a fraction. And you can see that because the limits are 0 and infinity, it's essentially killing the e. When we plug in infinity, it'll kill this, which will kill everything. When we plug in 0, it will kill the e. So let us apply the limits. So when you plug in infinity, you get 1 over 1 minus s times e to the infinity times 1 minus s, and that will be 0, because if you look at this part right here, e to the infinity minus infinity times the scalar s, this will go to infinity faster than this, which will make this 0, essentially, because this will be times 1, which is 0 in this case. So then, with the first part going to 0, we now have to subtract our second one. Now we have 1 over 1 minus s times e to the 0 times 1 minus s. This part goes to 0, e to the 0 goes to 1. So now you have negative 1 from this negative over 1 minus s times 1. And if we just use that negative to flip, we just get 1 over s minus 1. And that is our transform. So you can see it's a fraction. And for your function, no matter what it is, if it's e to the something, if it's sine, cosine, doesn't matter. It could be t to the something, it could be a 2 to the t. It will always go to a fraction because of the relationship between the negative exponent of e and your limits. This will always make something go into the denominator because this is negative, and it will always kill the e because of what these two are. So that is a basic transform, and if you have a full-on differential equation problem, all you have to do is transform each part, and then that's where you will use partial fractions. So I will go over that next. Thank you.